I believe this is the next problem that we had on the note sheet, is this one here. All right, guys, let's focus in. So what we're doing today is we're finishing up the note sheet. We're going to do a few more of these so that we can kind of get a little more comfortable with long division, and then the rest of the time will be spent for y'all, or you can spend the rest of the time doing the assignment. So first thing in long division is well setting up the problem. So I'll have our long division symbol. Our expression after the division sign will go outside. And our expression before the symbol will go inside. And again, in either case, the expression outside or the expression inside, we need to have every single term accounted for. So our one on the outside, the biggest term was x squared, which means we'll need an x squared term, an x term, and a constant term, the term without a variable. We do have x squared x in our constant. Inside, our biggest term is x to the fourth, which means we need an x to the fourth, x third, x squared, x for the first, or just x, and our constant term. We do have our x to the fourth, but we do not have an x to the third term. So we add it in as 0 times x to the third, which in most cases in points would just be 0, but we include it as more of a placeholder. And we have our plus 2x squared minus x plus 5. We don't have to add any other terms because that was the only one missing. Now the next step in solving this is trying to make each term inside the radical as the farthest left cancel them out one at a time. And the first one we need to cancel out is our x to the fourth. So we need to see what times our x squared will give us x to the fourth. Well, the numbers in front of both x squared and x to the fourth are already 1, so we don't have a number that we're going to multiply it by. So it would be x squared. Another way we could get at that is counting terms for the starting one, because here what we're dividing this by has 3 terms. So I'm going to go 3 terms over here. 1, 2, 3. The third term over is our x squared term, which means the first number we're going to, or expression we're multiplying should have an x squared. But that also tells us that the variable or term after it should have x, and the one after that should be a constant. It's just decreasing the exponent by 1. The constant terms variable, as we follow this logic, because we're going 2, 1, 0, but anything to the 0 power is 1, so we don't list it because it'd be a multiplication of 1. As we said, the next one should have x and then just a number. So for our first multiplication, we're going to use x squared. So we're going to multiply x squared by our expression that we're dividing this other polynomial by. So we're going to multiply x squared by our x squared minus x plus 1. We're going to distribute. X squared times x squared is x to the fourth, which is indeed what we want that first term to be. They do match up now. We'll do x squared times negative x, which is negative x cubed. And lastly, x squared times 1, which would be plus x squared. At this point here, x to the fourth minus x cubed plus x squared. We line them up, put them underneath each of the terms. And then our next step is to subtract. Questions on this so far? X to the fourth minus x to the fourth is 0. 0x cubed minus negative x cubed. X cubed, positive x cubed. Because our negative and negative would make a positive. And 0 plus 1 is 1. And we have our x cubed. Our next one, 2x squared minus x squared, would be plus x squared, because our 2 minus 1 would be 1, and we have our x squared term. Our next step after this is to bring down our next term, which is negative x. Questions on our first set of steps? Repeat it again. We're going to repeat the process again. This time we need to see what times x squared is x to the third. Well, the number that we need, number in front of x squared is 1, number in front of x cubed is 1, so we don't have a number we need to multiply it by. X squared's positive, x cubed's positive, so we know whatever the term is going to be should also be positive. And well, the next variable we said according to our setup should be x, yes? X squared times x is indeed x to the third, yes? So all we're doing is multiplying this by x, 1x. X times x squared is x to the third. X times negative x is negative x squared. And x times 1 is plus x. Any questions on any of this here, or anything that's not making sense? Anything we've done so far that you're not quite clear on? Okay. At this point here, we're going to subtract x to the third minus x to the third is 0. X squared minus negative x squared, 1 minus negative 1. Well, the negative and negative would make a positive 2x squared. Our next one, negative x minus x, would be negative 2x. And the last thing we need to do is bring down the 5, plus 5. And lastly, we need to see what times x squared gives us 2x squared, yes? Well, the number in front of x squared is 1. The number in front of our x squared that we're trying to match it to is 2. So we will have a 2. Yes, it will be plus 2. Because the 2x squared is positive, our x squared is positive, so the signs already match. So we'll leave that alone. What we have up here and what we're dividing by is x squared. What we're trying to match it to is already x squared, so we don't need a variable. And that also kind of matches the pattern we stated earlier, x squared, x, constant. So what we need to multiply lastly with is 2. So we're doing 2 times our x squared minus x plus 1. 2 times x squared is 2x squared. 2 times negative x is negative 2x. And 2 times 1 is plus 2. Any questions on this here before we subtract? So if we look at our subtraction, 2x squared minus 2x squared is 0. Negative 2x minus negative 2x. It would be 0. Because negative negative makes a plus. So we have negative 2 plus 2, which is 0. And 5 minus 2 is 3. So we do have to add the remainder back in. So it'd be plus 3 over our x squared minus x plus 1. And that's fine, because the degree of the top of our remainder is 0, because there's not a variable, so the degree is 0. The degree of the denominator is 2, so it works out. And realistically, I didn't state this yesterday, but if we think of this in terms of numbers, all we're saying is that the numerator is smaller than the denominator. Number-wise, let's get a different color. All we're saying is that it'd be something like 4/9. That what's left over is smaller than what we're dividing by, so we're done. Questions on this here? Let's see what we have left. I think we're starting to get the hang of this. Yes? I think one more will probably be good. I don't think doing 3 more is going to be any more impactful. And looking at the last ones that we have, I think this one's going to be the most helpful. Because I know the one before it is a lot bigger, because it's 2x to the 5th plus x to the 4th minus 15x cubed minus 2x squared plus 10x minus 24. But every term is there. Our x squared minus x minus 4, every term is there. Here, inside our division, the first term is x to the 4th, yes? But it's missing an x to the 3rd, so we do have to add that back in. We do have our x squared. It is missing the x, so we do have our constant term. And that's not unusual. We've had missing terms before. I believe this is the first one where the missing terms weren't actually next to each other. Because I think most of the ones we've had so far, we were missing 1 or 2 terms, and if it was 2, they were next to each other. It doesn't make a difference where they're missing. We just have to add the 0 in. Outside, we have our x squared term plus, do we have our x term? Nope. So even on the outside, we do need to add those in. It seems like this is going to cause an issue, but it won't. It'll just be a little weird because we will have to keep that 0x as it is. We will put the powers, if there are powers, with it, but it's still going to end up being 0. And the steps do hold true. Because if we look at this here, the first step is to see what do we need to multiply x squared by to get x to the 4th, x squared. Now also counting terms, if we counted terms, we have 3 terms outside. If I go over 3 terms, we have our x squared. We get that there. It also means the next term we would multiply after our first one would be a number with x, and the last one is going to be a constant term. And again, just like the previous, what we're going to start off with is multiplying what we're dividing this by with x squared. So we'll have our x squared times our x squared plus 0x plus 9. X squared times x squared is x to the 4th plus 0x cubed. Because anything times 0, we're used to just making it 0 and writing it off. But here, we still need it with how we're working these. It's going to end up being inconsequential in the end, but it's still good to have it there. X squared times 9, 9x squared, yes. And now we're going to subtract. X to the fourth minus x to the fourth is 0. Incidentally, 0x cubed minus 0x cubed is 0. I'm going to write this out. There's two ways we could do this. I'll show you both. Is we could say that this is 0x cubed. 4x squared minus 9x squared is negative 5x squared. And we could leave it as this here. And then I'll get my purple color back out. And bring down the plus 0x. And we could go through the next step of saying what times x squared gives us 0x cubed. Well, we would have x, but we would also have what? Plus 0. Because the only way to turn 1 into 0 is multiplying it by 0, yes? And we could go through this step of saying 0x times x squared plus 0x plus, 0x cubed plus 0x squared plus 0x. Are we really adding anything to this? No. Because what we could do instead is say, okay, that first term is indeed 0. Bring the next term down. Because we have to bring the next term down because the overall terms that we have here is 2 without it. The number of terms we have up here is 3. So if we get rid of the 0x cubed, I need a third term to get this to actually divide. Now if I'd have continued more with this and we'd have said 0x cubed plus 0x squared plus 0x and did our subtraction like we've been doing, 0x cubed minus 0x cubed, that is indeed 0. Negative 5x squared minus 0x squared is negative 5x squared. 0x minus 0x is plus 0x. Which gives us, puts us right back at where we were indeed. Minus 45. So all that's telling us is that the middle term x, there is no middle term x, because it's 0 times it. But everything falls back in line, because we can say what times x squared gives us negative 5x squared. And that would be negative 5. Now this does give us an interesting solution, one that we haven't had before. Oh, I see also why you're probably confused, because I actually didn't multiply that other one out. Okay. It took me a minute to realize that, so, okay. Let me back up. So, okay. Let me do this multiplication, then we'll get to the next one of the actual negative 5. If we distributed this, 0x times x squared would be 0x cubed, because our 0 times 1 would be 0x times x squared would give us x cubed. 0x times 0x would be 0x squared, and 0x times 9, 0 times 9 is 0, and we have our x. And then we plug it underneath and subtract. That's a little, it's a hard concept to try to just suddenly wrap our head around because we're so used to anything times 0 is 0. Since it's 0, it's gone with addition and subtraction. We're so used to just immediately throwing it out that when we get something like this, it's kind of counterintuitive to what we're used to doing. So what can sometimes be easier is if we do have that 0, And it ends up being like this here. Highlighter instead of just underlining. Something like this here where it is 0 minus 0. We can go on and cross it out and bring our term down, which in our case would have just been, I'll erase all this here, I'll put it back. And I'm going to put it all back so that it kind of matches up with how your note sheets look. We have this here. We didn't bring down the plus 0x. We only have 2 terms. We need 3. We bring down the next term of negative 45 and continue on. Now, since in this case I had to bring 2 terms down, well, that means I just don't put anything in that spot. We put it into the spot of what the last term we brought down. Since the last term we brought down was the negative 45, our constant term, it just means our next one's going to be a constant. Does that kind of make sense? It's a weird snag in how this is set up and done, but both methods still hold true. We can kind of see that. It's just doing it this way how we kind of have to have the mental flexibility of saying 0x cubed plus 0x squared plus 0x without trying to simplify it. Bless you. Now the last thing we need to do is this multiplication of negative 5. Bless you. Now if we do this multiplication here, negative 5 times x squared is negative 5x squared. Negative 5 times 0x is plus 0x. And negative 5 times 9 is negative 45. And the last thing we're going to do is subtract. Negative 5x squared minus 5x squared. 0. 0x minus 0x is indeed 0. Negative 45 minus negative 45 is indeed 0. So the remainder is 0. It means they divide evenly. Which for us, because we can circle this up here, but we don't have to leave the 0x. What it's telling us is the solution is x squared minus 5. It's not wrong. It's just we normally don't put it there. But that's it. Questions on this here? Questions on anything we've done so far? Now the whole goal with this here, with dividing, is to help us solve these higher degree polynomial functions. And the reason we do this is because, well, at this point, we don't have any way to solve x to the 4th plus 4x squared minus 45. We will come across some methods that do help, that do work, but one thing we do know for sure, and what we've covered in the last chapter, not the one immediately before the break, but chapter 3 was how to solve quadratics, degree 2 functions, yes? So if I can find a way, or find enough solutions to take this from a degree 4 to a degree 2, we have ways to solve those. Because the x squared plus 9, we can solve it. It is a quadratic. We did our division and we turned it from a degree 4 down to a degree 2. We can solve those. And a lot of the methods that we're going to go over for solving these higher degree polynomial functions is going to be ways like this and synthetic division to reduce the power or the degree from 4 to 3, from 3 to 2. And if we can go from 2 to 1, that's even better. But get it down to a degree 2. But that is the end of that there. Homework. Well, I'm going to write the whole thing out. Here we go. Page. problems. 5 through 10. It is one of the text pins, so it detects the writing and tries to convert it into text. Sometimes it works well, sometimes it doesn't, because it doesn't understand what I'm trying to write.